Hi guys, welcome to my YouTube channel, and in today's video we will be discussing about the concept of CQRS and microservices. We will also understand the fundamental components of CQRS, and from the dev perspective we will also understand if somebody wants to implement the CQRS in the organization architecture, how can we implement that particular CQRS for the services, right, for microservices. So let's quickly begin with the CQRS. So if you look at the basic definition of CQRS, it says it's an architectural pattern that separates the read and write operations for architecture, right, for a system, for a data store, you could say. Now let's understand what is that particular problem that CQRS understands. Now, in order to understand that problem, let's begin with a small case study of an organization where we can apply the CQRS, right? So, and one update that this article that I'm presenting here, you can find that on suchet.substack.com, where I'm writing my all newsletters. I will I'll mention the link in my YouTube description. Okay. So let's first of all understand a case study. Let's say there is one organization, and then that particular organization has a monolithic architecture. Now, which is kind of not efficient nowadays. So that particular migration want to have a digital transformation and migrate its monolithic architecture to its microservices architecture. So while doing so, it's a retail chain, and they said that we generally get 30% of read for 70% of read calls, and only in a day we receive, for example, like 30% of the write calls, right? So in this scenario, if you see, we have a read heavy system in this retail chain, right? So this retail chain is majorly operating in the read operations, and they have kind of 30 to 40% of write operation, not much more than that. So write operation could be anything. For example, your admin in the inventory warehouses keep on adding products to the inventory, or let's say some customer is buying a product, so that could be a write order operation. So those kind of certain operation you can have in a retail chain. However, for example, if you go to Amazon store and you keep on scrolling your mobile application, you see a lot of products listing, right? So those kind of calls are nothing but the read operation. So we could consider that, although it's very lame example, but we could consider, just for understanding, that it's a read heavy system, right? So in the read heavy system, I have already showcased a diagram here. So you see, these are all the clients, and then this is the deployed solution, the existing deployed solution before migration for this retail chain. So we have 30% of write calls, and we have 70% of read calls. Now the problem you need to understand here is so there are several problems, I would say, rather, right? But there is one problem. Let's focus on one problem, and taking reference of that particular problem, we will understand what are different associate problem with this, right? So now, if I say that for this particular organization, I have, let's say, this architecture, right? Now, for my write services, let's say I have two instances of service running. So this is nothing but my write service, right? Write service, and this is, let's say, my read service, right? So I have separate write service and I have separate read service, but this is after CQRS implementation, this is after migration. But before that, understand the problem, then we will move on the solution, right? So now you have this monolithic solution. Let's say this is a kind of nothing but your production environment, and you have one service running. So let's say this is your retail app, and obviously a back-end retail app, not the front-end kind of, right? Now what happens is your load is increasing, right? So you have a load, let's say 10K, right, per day load, but your load is keep on increasing. So what you do, you come with a strategy. Okay, no problem. What we do is we will increase the number of replicas. That means we will horizontally scale this. So we will horizontally scale it, right? So that's one solution. Okay, so if you have, let's say, 50K load, then if your one replica is able to handle 10K, then I will rather have 5 replicas of same service, so which can make me to handle my 50k load, right? It's very simple math, and it's horizontal scaling. We have done nothing but the horizontal scaling. The problem is, you see, this particular component, this particular service has everything in it, right? It has, let's say, product related service, it has order related service, it has inventory related service, it has shipping related service. All those features I already have here. So you see, for running all those features inside one application, you might be using a lot of resources. So let's say these resources cost you some X amount, right? And also understand, when you have product feature in it, right, because of the fact you only want to scale your product feature, because most of the 30% of this 50k, 70% of your 50k users must be reading, sending the read calls to your system, and other 30% user must be sending write calls to your system, right? So I would say now because of to scale your read API, which is in your order and mostly in product, because what you do is you will read the products, right? You will read your orders, right? You will read your shipping, right? You will have to scale everything, right? When you are scaling this application, you will have to scale everything. Now you need to understand it's a read heavy system. So when you are scaling everything, you are increasing the resources unnecessary. There is no point of scaling your inventory. There is no point of scaling your create order features. There is no point of scaling your create product feature. There is no point of scaling your shipping feature, or there could be n number of different features. Now the point is, what we're doing here is we are unnecessarily scaling the features that we don't want to scale, right? And by doing so, we are putting extra cost just to manage the extra resources to maintain all these features in the production environment, right? So this is one aspect, one problem you see. It's a read heavy system. We don't want even feature, but still we are managing the multiple copies of all those features, right? So the solution, the basic solution could be that you pick out the right functionalities and put it into the separate microservices. So let's say what you did is you taken out all the right functionality and you put it here. So what you do, all your functionality related to your right product, create product, delete product, or update product, whatever. And for same for order, create order and your update order, delete order, etc., etc. And all those read functionality, what you did, you separated it, right, in the other services, right? Now that's one thing you did. Now second problem, the problem of scalability you understood, right? That unnecessary we are scaling up the resources, which is making me to cost extra, unnecessary for unnecessary resources. Second thing, if this architecture, the architecture or this monolithic is working, let's say on a database, right? If it's working on a relational database, so it is my relational database, right? So relational database, if you see from the search capability perspective, you won't find the better search capability in relational database, right? Although you can implement a lot of indexing and all those things, but the way your relational database works is because it's good for storing records but not for searching. So because let's say you have ID here and then you might be linking this ID here, so it's good for linking or have a relational database, but it's not good for your search capability, right? For your search, it's very bad. So you see, my read heavy system, although because of the fact I have read heavy system is 70%, then I should have a database, a data store which must have a capability of faster search. But if you see, I have a limitation because I'm using a relational database here, so I cannot scale in terms of my the search capability into data stores, right? Second thing, if you also see here, if I'm increasing my scale, if I'm scaling up my resources, I might have to scale my database as well, right? But you see, I only have 30% right call. What is the point of scaling the database along with all these replicas, right? So if you see, this is also adding the operational complexity, right? So one solution could be, as we already spoke about, that what we will do, we will simply take out all the write operations, put it into separate services, and we will take out all the read operation and put it into the separate service, right? Now the problem of, let's talk about the problem of database. What we will do, we will make it work with this database, and this could be a relational database, right? and then this is because I want this domain needs to be work as the faster search capability. So I would rather not work with the relational database. I would rather have something which is much faster in terms of my read. So I might have a document oriented database here, right? So it is nothing but a document oriented DB. Then let's say it's kind of a MongoDB, not Cassandra. Cassandra is faster in terms of write operation, not in terms of Mongo, right? Or you could have a Solar Index, right? You could have Elastic. So all those document oriented database you could have. So this will take care of your read, and this will take care of your write, right? Now solving this problem by taking out all your services and separating it into different domains along with the different data stores is nothing but your CQRS, right? That's what I said. Command Query Responsibility Segregation. So you see, this particular guy, this monolithic application had everything. It also had my command. So command is indicating your write operations. Your create operation could be your update operation, could be your delete operation. Your query part is indicating your read operations, which is nothing but your get operations, right? Responsibility segregation. So what you're doing is all those command and query, you are separating it out and putting into different services. That way, now if you see, the major advantage of this could be that, let's say you have the write operation, you have your read operation, you only have your 30% here for the write, and then you have 70% right here. If I want to scale, if this is my read heavy system, right? Read heavy system. If I want to scale, if I want to enhance my database, if I want to enhance my read search capability, I will simply scale this read services, right? Read services. I will not scale the write services. So you see, all the capability, all the resources that are being used for write are still there. I'm not putting my extra cost, resources, energy, time for managing all this complexity for write. I'm only scaling the read related services. It could be database as well. If I want to scale, I will scale my read database, right? Mongo, Solar, whatever. I will not touch my relational database. So this is the major advantage that you could have by using by using CQRS in your architecture, right? So let's go back to our documentation and understand it a little more. So as I said already, that on a high level, for above deployment solution, we will separate the write and read domains, right? So we basically had a look that this particular solution is serving all type of calls. It could be create, delete, update, or read. You see, even the organization is saying that they only receive around 30%, it's not very specific, around 30% of write calls and 70% of read calls. So the major solution that comes as part of CQRS is, what you do is you separate out all the read and write operation. To read operation, you call it as query model, and domain you will say, and then the write you will say, the command you will see the write domain, right? So these are the clients that are sending your write commands. So let's say create, delete, or update, or these are the clients that are sending your read commands, right? So the benefit, as I said, the benefits, first of all, the benefit of scalability, I have already mentioned. If you go back to the video, I explained by drawing the design that how we are enhancing the scale, right, effectively. Performance, as I said, because one monolithic application will if you are breaking it down, you are separating out all the services with the separate features, so what service can work well, right? Separating our concern, as I said, and flexibility, as I said, that for writing and reading, so what you're doing is you are making your services smaller. So smaller services will help you in everything, in implementing your CI/CD easily. If a developer wants to make a change in a particular service, he or she can make that particular change easily. If you want to scale it, you can scale it very easily. So there are a number of benefits that you can get as part of your CQRS, right? Now comes our most important part. So let's say this was a 10,000 feet over diagram, that how you will be implementing the CQRS just at a domain level. Now we will understand same at we will go in the depth and understand the architecture diagram. So let's say you will have your clients here. you will have your clients here, right? And then you have load balancer in between. All calls are going via your load balancer. So let's say you can consume it's a diagram right from a component level, not from the deployment level, because if you write a deployment solution diagram, then you could rather be implementing this solution in Kubernetes as part of the modern backend engineering, right? Because most of the organization have started using Kubernetes in the cloud, etc., so on. So these could be your pod, but we are writing the component level solution diagram. So you have divided is you have created different write APIs here, right? And then you have your relational database, and then you have taken out the read related functionality to different services, and you are calling it as read API. Let's assume that for that particular moment you have 2 current replicas running for write APIs and 3 for your read. So you have is 2:3 ratio kind of. And again, you have this flexibility to independently scale the query domain or the command domain, right? Since you have separated it out. But importantly, because now you want to make your search faster, the search functionality is coming from your read API. So you have implemented a cache. You don't have to use cache, right? Because so you see, cache needs to be maintained only at the query level, at this service level, not at this level. So again, this is again another benefit of CQRS, right? So it's very separation of concern, right? And then it's flexible. Now, because you want to make search faster, you are not using relational database, because relational database is not good for faster search. Rather, you are using some kind of document DB. So document DB could be anything you can pick up from MongoDB, Solr, Elastic, anything, right? And then for example, you have your v1 write API. You are sending a JSON body, and this will be a post call, put call, delete call. And here most of the calls will be get API calls, right? Because you will be querying something. So that data will be coming out from the document database, right? So now let's understand one flow, right? Because this part I have not spoken about so far. So it's very important part. So let's go through the flow and then we will understand. So let's say somebody writes a product, right? So let's say there is one user and then there is one guy, admin, who is creating a product. Now in your Amazon application, for example, if you're scrolling an e-commerce application, you're scrolling, you will see a product, but that particular product is being added by some kind of admin, some kind of seller. But the point is, you will only see that particular product if that seller adds it, right? Admin adds it, seller or admin, whatever you want to say. So let's say this guy has added a product. So eventually that particular client, if he's or adding from an Android application, iOS, or from a web, so there will be a call that will go to this particular write domain, and then this will go to write API. Write API will create a product in the relational database, right? But remember, there are clients, there are you. For example, you are sitting right here and scrolling your e-commerce application, and right at that moment you see that product. Now how will you see that product? Because you are writing this product into this relational database, but you are querying from this document database. So now there has to be a data synchronization that needs to be happen among these two databases, right? So this is where the concept of event sourcing comes in. So you could use event sourcing. How? Because right at the moment a product will be created in the relational database. It's very important, please understand, right? So right at the moment a product has been created into relational database, at the same time an event will be created, right? So your event might say that this particular product has been created, this is the time it has been created successfully. So this event will be sent, an event will be emitted, it will be sent to this particular queue. Now this is nothing but your broker. You may use Kafka, you may use Active, you may use RabbitMQ. It could be anything. That again depends. It's a fundamental implementation, could be anything, right? And then from here, since you have an event, now this guy needs to understand, right, that okay, there is an event, I have to consume it. So for now, let's assume that this particular event is being consumed by document DB, and then from the event it basically extracted out the important information that this particular has been added. So from the event, that particular product will be updated into document database. So there will be some delay because again you need to understand that there needs to be error handling, right? Because what happens if this particular component fails? So the entire foundation of CQRS will fail, right? You will not have your regular updates in your document database from your relational database. Now, so we understood, okay, from this part that data synchronization needs to be happen from your command domain to your query domain, and that data synchronization can be done using your event sourcing. So the concept of event sourcing one can implement using your frameworks. Second, you have something known as this particular process, right? Capturing this change, right, and updating it here. This is also known as, by the way, CDC, change data capture. So a data that has been updated right here, it needs to be captured right here. So you have to update CDC. Now there are ways to implement your CDC, right? And whatever I have spoken, right, whatever I said is being written right here. So you can go to my documentation, this is my newsletter, and understand in the depth, right? But let's understand. So as part of CDC, so it's a new term for you guys maybe. So as part of CDC, what you're doing is you are capturing the change that has been done in your relational database, in your command model, and updating it into query model, right? Let's go back and understand. So let's say this is your write service and this is the database, right? And then this is your read service, and then this is another database. So there is a guy that has added a product. Let's say it has added product P1. So successfully this write operation has been done, and then this guy has product P1, right? Now here you have, what you have is your Kafka broker. Let's say here I'm taking example of Kafka. You could, so this is the implementation that we are understanding, that we are trying to understand using Kafka and let's say event sourcing by framework. Now this guy will basically emit an event and put it here. So it will say event for P1, right? Or it will say event is for what? Event for create, right? So this event will go here. So let's represent this particular event by E1. Now this guy has your all the events, right, in your topic. So this guy has your E1. This particular service, let's say, is keep on reading to your this Kafka topic. So this is your broker. It will read that E1 consume write. It will see that it's a create event for your P1. So it will update the P1 here, right here. So now this guy will also have P1. Now when this guy will come in, and let's say he scrolled his e-commerce app, so there will be in the background your mobile application will send an API call. So it will say your get new products, and then it will, as part of many products, it will also send your P1, right? So that's 1, that's 2, that's 3, that's 4, and that's 5, and that's 6, and that's 7. So that's overall your life cycle of all your the update that has been done here, and which is later now captured into here. So these are two different data stores, right? And this particular part, this 3 and 4, this is nothing but your CDC, change data capture. Okay, now see, this is the manual way of CDC. You see, there's choice, you have your choice. Many people, you can implement your manual CDC using some kind of let's say Spring Boot event sourcing, or some kind of Exxon framework, or any framework, right? There are various frameworks you can utilize it. Many people, what they did, they don't implement this kind of CDC. They rather what they do is they use some kind of connector. So there are connectors available. For example, if you are using Kafka, then you might have if you go here, right, you'll see I have also written the connector here, the CDC source connector, right? So there are different tools available. For example, if you, I don't know if you know Debezium, and then Kafka source connector and sync connector. So what you could do, you can, as part of your Kafka deployment, you could have a Kafka source connector. That source connector will be listening on a particular table. It will have its configuration. It will be I have created a video as well for deploying the data platform using Kafka, Confluent Kafka. You can go and visit, but that's very in-depth deployment. I don't know if you will understand, but this video is kind of a system design related. So that particular connector will automatically listen to your database table and create an event automatically. You don't have to code and create any application for that, or you don't have to write any consumer in your read application. So what you're doing, you're separating the concern of emitting the event or listening the event, right? And then that source connector will create an event and put it into your Kafka topic, and from your Kafka topic there will be a sync connector. Again, Kafka sync connector. Again, it will also have a configuration to link it with the MongoDB. It will read that particular event, update it to your document. So your CDC part will be done separately and will be done automatically using your Kafka source and sync connector, right? So this is another way you can implement the data synchronization CDC between these two different data stores, right, here to here. Alright guys, so as part of this video we understood the fundamental of CQRS, right? We also understand what is the basic need of CQRS. We also understood that what is the solution that CQRS provides, right, presents, what are the benefits of CQRS. We also did a deep dive into the implementation of CQRS if we want to do it in the microservice architecture. We also understood the overall flow, right, using design. We also understood how the CDC will work. We also understood that how many ways we can implement a CDC. So if your organization presents, if you're in a meeting or you are anywhere, right, you can always put up your thoughts on CQRS on the table in front of your management. So I hope you must learn something about CQRS as part of this video. If you have any suggestion or feedback, you can comment it down. You can reach out to me on LinkedIn. So far we discussed CQRS. In the next video we'll probably come up with some other topic. So thank you so much guys.